All right, folks. I know we're on day two, the second half of day two after lunch. What possible pain can we go through? So this is going to be a nice, gentle, ranty talk with little technical detail, not too stressful, not too challenging, and most importantly, I cut out most of the weird shit. So a little bit about me, just a little bit of boring background, long list of weird shit that I've been up to in the past couple of years. So backgrounds in electronics and software engineering, spent some time in telecom, some marketing and advertising consultancy, somehow decided it was a good idea to start a charity, then spent some time working for the Ministry of Defence, did some journalism, did some director of R&D stuff for a couple of different startups, drifted into data science because I accidentally started using numbers to solve problems, spent the past couple of years working in the cybersecurity field, and on tomorrow I start my first day of a new job, so that's why, yeah, so I had to change these slides a little bit earlier just to make sure that I didn't have any of the old company's name, and that would have got me in trouble. So previous rants in no particular order. I've ranted about open data, about autonomy and defense. I once did the stupidest talk idea that I've ever had, which was a alcohol-fueled live coding a recurrent neural network to do blockchain speculative sort of market forecast for building bots. That didn't go well. What went much better was a scalable analytics talk on Dask. That was bringing Belfast. Yes, Belfast does have a Python scene, and a few other weird stuff in there as well. So, the obligatory Brexit comments. One, I have my get out of Brexit free card anyway, so I really don't give a shit. Two, I wish this slide was shown to every single UK politician a couple of years ago, because it would have solved an awful lot of problems. I actually am one of the people who put together this site. So this is how long has it been since Northern Ireland had a government.com. I also, at the same time, bought how long has it been since the UK had a government.com. Got to use that one recently for only a couple of days, but sure, it was fun. So today marks 1,000 days of Northern Ireland continuing to be pointless. And our politicians continuing to be pointless. And I know I said that we would keep it light and fluffy, but unfortunately the implications for some of these situations aren't quite so light and fluffy. So people, it is very easy to joke about the challenges that Brexit's throwing onto this island. We just have to remember that we spent a long time getting to the point where those kind of things were jokes and not life-threatening. So, with all that shit out of the way, we've got the first question. What is a hackerspace? Before we go into the really weird words like timeseries. A hackerspace is where a group of hooded individuals come together to steal your credit card details, sniff your Wi-Fi, and basically manipulate social networks and break things. Yeah, no. The vast majority of the time, and the vast majority of the hackerspaces that I've had the pleasure of dealing with, it's scenes more like this, where it's people coming together around technology, sharing their knowledge, sharing their resources, sharing their experiences in a free and open fashion. This is a prompt ramble. But the word hackerspace is kind of part of a family of phrases that's much wider and more diverse than that. So we're looking at hackerspaces, makerspaces, fab labs, tool libraries, and these things can have multiple purposes. Some of them are literally just workshops that have a toolbox in the corner, or maybe some specialized equipment like laser cutters and stuff. Others are event venues or classrooms. Some can be corporate, some can be run by local councils, some can be pay for, some can be voluntary, some can be public. There's now a trend at the minute of every bloody university on the planet building their own makerspace and not letting anyone else in. Some can be described as exclusive cults, or as crack dens, and or as dumping grounds. And some of the people can either be advocates or teachers or just people wanting to experiment. So, Farset Labs. For anyone who wants to know, the reason why it's called Farset Labs is that Belfast is actually named after a river called the River Farset, and I should have actually gone for the laser pointer. But it's actually a bit weird. We originally picked the name before we picked the location. Unfortunately, the river itself is like, see where it says the A501? It's up there, so we kind of didn't really get that right. So we'll see if we can, well, we've survived for 8 years, so that'll do. So yeah, as it stands at the minute, we're based out of, actually it's an old schoolhouse for the linen mill. So the building dates to 1883 as far as we can tell. We've got 80 due-paying members, 5 voluntary directors, 5 voluntary managers. The only differential between the directors and the managers is that the directors are legally responsible for whenever anything goes to shit. We're a combined co-working event space and workspace. As I say, we've been survived as a voluntary and community organization for 8 years, which is better than most in Northern Ireland, but there we go. And we operate primarily focused on the community. The idea is bringing the people together, sharing, bulk buys of hardware coming in. We coordinate with disposing of sort of leftover office equipment, make sure it's being used for appropriate use cases, and also representing the wider tech community in different social and community affairs. We do an awful lot of education and outreach, so whether that's teaching policymakers how to understand the sort of network topography of roads and using network theory to understand why these points are particularly heavy for traffic jams, there was another guy who was doing a talk on, he had monitored his newborn's feeding and sleeping patterns and actually using that data and that sort of monitoring to actually improve his medical care because it was able to very easily explain to the medical professional, here's how my child is experiencing their life in a very visual, visceral way. We also do loads of weird shit, so projection mapping. We've got a table that's basically, I think it's about 1,000 little sort of RGB LEDs that actually ended up being turned into a ping pong table that's acoustic sensitive. So if this works, where it actually responds to where the ping pongs land, which is quite cool for doing some interactive games. So you can do weird shit like this, if this works. Conference Wi-Fi. So that's 2 people playing in the dark where the ball's effectively chasing back and forth. That's really cool. Yeah, there's a backup sleeve, yeah. So where I think Farset Labs sits in the grand world is in this intersection between the arts and tech worlds. So where we find all the really interesting magic, but we can extend that magic in different ways. This is Mary Louise. I can't remember which of the number of medical disorders that she's currently suffering from, but one of the things that we tried to do for her was basically create a musical instrument that she could operate. So she's wheelchair bound, has severe cognitive difficulties, and basically we sort of have been working on doing motion sensitive music creation. That ended up resulting in a sort of big concert, I suppose you would call it, in collaboration with Queen's University Belfast Sonic Arts Research Centre. There's another guy, that video is not going to work, but this is Ewan, who you might have seen for a bit, but that was just a different system, but it was using suck blow switches and a motion sensor on his arm to play a virtual guitar, which was a lot of fun. We also push for things like pushing open data and transparency, representations to city councils. We work with different blah, 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 blah. But how the hell do we monitor and manage all of this shit? So this is our primary sort of suite at the minute. I put the asterisks up there because for our regex friends, there is never such a thing as a single Raspberry Pi. You always have to have at least 6 doing stuff that you didn't write down anywhere. But that's how we're monitoring the building. All of our finance is done through Xero, which provides a nice Python API, by the way. We do all of our scheduling through G Suite and Google Calendar, which provides a nice Python API, by the way. And all of our primary hosting is done through GitHub and GitHub Actions and things like that. This year we're rolling out Nexus, so it's a new management system. It has nice Python API backends, by the way, and Ubiquity for occupancy monitoring and Wi-Fi. So 8 years, everything was going well, and then we had this past year, which I can only describe as a year of hell, where basically, I should have swung back, but we got word that our upstairs tenants were buggering off. Skim through it if you like, but realistically, we've had 11 months where we haven't been able to book, plan, or fund any programs or hiring out the event space because of the joyous negotiations bouncing back and forth between contractors, architects, landlords, and us. We are so close, so ridiculously close, that the photos that we basically spent so long scribbling on these plans to try and make some kind of compromise that matches between the landlord's expectations of money and not spending it, and our expectations of having a building that was fit for purpose. So this is what our event space would normally look like, and occasionally now, I think we used to, it's now gone, but we used to have the largest blackboard in Ireland, which is a nice claim to fame, and we'd regularly be having education or social events, and we had what can only be described as an Aladdin's cave of a workshop that was just a junkyard, to be perfectly honest. And all of this forced us to end up turning it into something that looks more like this. So this was a couple of weeks ago, whenever everything had to be torn out. We basically had to move house, scaling from 2,000 square feet down to a temporary unit at 500 square feet. That was not fun. And then this was last week, I think. And then this was the other side a couple of weeks before. And that's what it looks like now. So a little bit of a transformation. I personally don't like the clean lines. It's all a little bit too clinical for me, but I'm sure we'll break it soon enough. New workshop, so all purpose-built electricals coming in to make sure that we can run some really nice, sexy kit. Laser cutters first on the list. If I don't get my goddamn laser cutter, somebody's getting shot. New co-working space, so we're going to have loads of space for everybody to actually work on stuff. But wait, the entire point of this was that we get upstairs. We'd get upstairs. So more scribbling on plans to get rid of loads of walls. And as part of the process, we ended up accidentally with the largest toilet in Northern Ireland. No, it was not used. I hope not, but we'll see. And that's now like this. So we've now got an additional space for about 45 to 50 startups, students, entrepreneurs, just people wanting to experiment with their own stuff. It's going to be a nice expansion to the family. But all of this expansion, all of this change, how on earth do we actually say to anybody, yeah, we've got 8 years, we're actually going to be here for a little bit longer, so trust us, it's okay to make these kind of investments. We're not quite circling the drain yet. This is the fundamental model for any hackerspace or makerspace or co-working space. It is fairly simple. Members pay their dues, external people book venues for hire, and kind people donate. We are a registered charity, so that makes that much more useful from tax purposes. And in exchange for that, the space itself makes sure that we look after the rent, look after the overheads, look after the equipment, look after the consumables. And one of the first questions that we wanted to have was, if we're doing this expansion, are we expanding? Have we been expanding? Is there a market need for this? Are we actually feeling the pressure that we think we have? And this is when we start going into financial modeling. If someone can track down the source of this picture, because I've seen it in a couple of places, please let me know, because I'd like to properly attribute it. But it is a pretty good explanation of what I think happens to everybody with their maths education. Yeah, we'll get the photo on that one. Take your time. There we go. So, financial modeling. Zero is great, but whenever the kind of reports it presents to you look like, I don't know, it looks like a betting sheet to me, and this is completely unintelligible. Fortunately, as I said, they do have nice Pythonic APIs that let you access these reports and turn them into something useful. Now, I'm doing this exact same thing as everyone else at this conference, which is chuck it at Pandas and hope it doesn't fuck it up. So yeah, we end up with this kind of mess of what did we get in and what did we send out. But how on earth do we actually make sense of all this? How do we dial down to try and see what's actually going on? So we use our friendly plotting library and go, oh, look, we do have time series data. See, it was in the title. But there's a couple of things that all just look pretty weird in here. So there's all these spikes all over the place that range in reasons from us literally being sued for being hackers, and then their lawyers went on holiday and then didn't pick it up. There's also weirder, more systemic constraints, such as if we are doing externally funded programs, they'll usually have like a spike of income, but then the expenses get spread out over a couple of months. And then there are years where that's good, there are years when that's bad. There's also more sort of operational things where you can see around here we changed from a quarterly rent payment to a monthly rent payment. And then we were doing well, paid more than we needed to, and then the money just disappeared into a pit. So yeah, not making that mistake again. But also there's human errors. So there's like an invoicing error that was over Christmas that nobody noticed. There was an incoming donation that was miscategorized, and that kind of thing. The kind of things that make data sets funky. And I mean, we're all familiar with the pain of data cleaning. And unfortunately, in this case, we've got no one else to blame. Normally, you can blame it on some data owner and say, here, do your shit properly. This is unfortunately the real world and the real variations that we have to deal with. Same kind of thing with the money coming in. So again, if we have external programs paid in, it could look like just a big spike, but we need to bear that in mind. We also have variations in how people interact with the space. So most people are on monthly membership. Some people are on annual membership. So they end up, and for some reason, people seem to do them in the new year. I think it's like the technical version of getting a gym membership. So these end up sort of bucketing together where you have these spikes. And again, we've got human error, people just miscategorizing things on the accounts. And then you get the random sort of stochastic events of like a one-off donation and those kind of things. So in any kind of way of trying to understand this and trying to see the wood for the trees, we've got this noisy data set coming in. How can we start to see what's the overall trend on this? We have to sort of think about, yes, it was in the title, the difference between what kind of things are affecting this time series, what is affecting this progression. So there's the two words that pop up around is exogenous and endogenous variables. Sounds really, really fancy and complicated, which is exactly why I put it in the submission talk title. But it fundamentally breaks down to, is it an outside factor or is it an inside factor? Is it a factor that your model can influence, or is effectively an internal term to your model, or is it something that's completely outside your control and affects you more than anything else? So yeah, summary. Exogenous examples: rent, rates, foreign exchange, the cost of electricity. These are just things that change over time, but they don't necessarily have any control over, or you don't have any control over them. Endogenous is a bit of a weirder one because it's not just things that you, inverted commas, control, but they are part of the overall model that feed back into itself. So this is things like the number of members, the sort of velocity of event bookings, and whether you're able to satisfy your charitable reserves policies and things like that. So we wanted to say, are members actually paying their dues, and is it on an upward swing? So we just pull out stats models. Hands up who's used stats models. Okay, I was going to go for the second one, which does anyone actually understand what magic is happening under the hood? Because I don't. I just know that it works. It seems to give answers that make sense. But it's a really fantastic library to play with, and just makes things an awful lot easier. But for the love of God, they need a better logo. Yeah. So we can just isolate this out just as an example and just go, right, okay, what's the membership dues per month? Right, so hands up who thinks that's an upward trend. Okay, hands up who thinks it's a downward trend. Hands up who isn't sure because it's too noisy. There we go. Right answer, we need to test it. So stats models, time series analysis submodule has this fantastic seasonal decompose function that also presents these really, relatively easy to understand graphs. So your top row there is the raw value, the observed value that you gave it in the first place. This second one is what sort of the idea is the trend, the overall movement of that variable. So for everyone who said that they thought it was trending up, thanks, you were right. This seasonal component, this third one, this is the one that was quite interesting, especially whenever I was talking about the annual memberships. This is effectively isolated those into their own section, extracted those, and this is leaving us with, if we can explain this as I think this looks like a roughly annual pattern, then once we take that into account, that bodes well for the idea of actually being able to predict some of this in the future. And an interesting one to throw in that often gets left behind, ironically enough, because it is the residual. The residual at the bottom is an interesting one. It's effectively what was left over whenever the seasonal decompose tried to make its best bet of how things fit together. So this is, for instance, that section you would maybe, if you were doing this with your own data, you would maybe want to see, right, hold on, what operationally happened that caused that large residual at that time, because there was something funky going on. So we're fairly confident that the membership paying their dues, that's on the up and up. We think we might have some optimism about that one, just looking backwards. Second question, how's the external bookings going? So this one we basically literally grabbed from our Google Calendar iCal, dragged down the events, worked out how long each event was, and then basically grouped that by I think it was by the month? Yeah. So we can see that there's a load of big spiky events. I can tell you that those were 48-hour hackathons, and then, yeah, things don't necessarily look so good. Whenever we do the same kind of seasonal decomposition, we actually found some interesting ones. Whenever with our understanding of the data set, we were able to go, right, why did that happen? So this big peak, we thought it was originally the hackathons. It wasn't. Whenever we went back, it was actually the most common that we were being booked for community meetups. So this was whenever everybody and their brother wanted to have a meetup, but it was before the big financial and software firms had realized that they can host them themselves, and it is cheaper than sponsoring community-driven projects that you shouldn't be butchering to use as recruitment farms. But the other thing that we noticed was that, going back to the timeline earlier, the actual event bookings velocity was killed as soon as we said anything about, right, we might not be able to book the space in 3 months' time because we might be being in the middle of renovations. So this is something that is probably killing us, and that we need to put additional operational effort into making sure that that is brought back up again in the new world. So we're not sure. We think we can explain all the factors in the external bookings venue, or external venue booking. As I said earlier, the prediction of donations is so far outside of predictability that we literally don't have enough data to start playing with it. But we do have some information to be able to start to model these processes, particularly the membership income, because as you saw from the very early slide, it's more than 50% of our revenue. So it's the most important thing to making sure that we're actually still here in a year. So there's a load of time series models, and I'm only going to be focusing on the sort of univariate for the explanations. The multivariate fell off the optimistic bandwagon. But we're looking at, autoregression is basically some linear function applied to a previous value or the previous two values, for instance. Moving average, same kind of thing, except you're doing an aggregate over those previous values first before you then model what comes next. Our ARMA is just a combination of both, and then ARIMA, so autoregressive integrated moving average, is same idea, except you have a sensitivity to how large, if there's a large step, it'll effectively be able to dampen that down. So very, very useful for potentially spiky or noisy data. But none of those really take into account long-term patterns or seasonal variations. Now, we keep using the word seasonal, and the documentation all continually uses the word seasonal, so it implies that it's something that has an annual cycle, but it's got nothing to do with that. It could be any periodicity at all. It does not matter. I've used this stuff in the past for doing things down to the millisecond, or that does not matter. So seasonal ARIMA is the one that we're going to be playing with most, which is just effectively if you think about it like a ring buffer on top of the moving average is probably the easiest analogy. And then this idea of the exogenous regressors is where, in theory, you give it some extra contextual secondary knowledge outside of the time series to say, here, dear model, this might help you understand some of the correlations between the data. So with the joyous time series analysis, library, this is actually fantastically simple. This is, once you've done all your cleaning on all of your reports coming in from zero, that's just a pandas data frame we all know and love. Yes, it is one of the rare uses of usages of actually using hierarchical column indexes, but here, forgive me. And just for our purposes, I've trimmed this down to just, while we're doing the modeling, just up to the 2019. So that we counted that as effectively being before any of the major impacts of the news of the renovation would have fucked with the model. Now, there's a couple of terms in here. Our Y is literally, yeah, it is just our input. That's fine. The order, the way to think about this is that this is your autoregressive term. This is your integral term, and this, no, moving average term, and this is your integral term. We can actually see later that doesn't make much of a difference. Then your seasonal order is basically the same thing, but effectively mapping onto the order of that moving average, that buffer, and that sort of expanding range buffer. So these are literally just guesses. It's, I think there's a dependency on the moving average with a single order, so that's a linear function. I'm not massively convinced that there's a direct correlation to the immediately previous value, and I think there might be something to do with the steppiness. I think I wouldn't expect there to be big steps, so take that into account whenever you're building your model. In terms of the seasonal, it's more or less the same thing, except I'm not as confident about there being steps. I don't think there's going to be that much of a big change. There's going to be an overall trend in the year, but it's not going to be steppy. And then enforced stationarity, it's a bit weird, but it basically says, if you're doing a model on something that you expect to stay level and you want to find the trend, and you're more interested in the location in the season rather than actually forecasting the trend. And then I honestly can't remember what enforced invertibility means, but it was in the docs that I copied, so yeah. Same as every other modeling, you just fit it onto your data, and you get a load of numbers that don't really make any sense to anybody, so yeah, fine, whatever. Let's just go, oh shit, right, who said flat? Oh crap, right, oh, this is all doomed. Why do we, no, right, fine. So, this has come up a couple of times in a couple of different people's talks, so I won't try and repeat it, but the short answer is that one of the most fun things about doing these modeling loops or these machine learning loops is that you always have this loop around of you try to predict the future, you assess your predictions, which is basically, did the model tell you what you wanted it to say? And then you pick a stat to optimize for. So this can be your false positive rate or your error rate or your RMS squared error, or literally in this case, the direction of the line. And then you basically tweak the model and then try it again until you get something that's good. This is fine. I am, on the other hand, really, really lazy and had time to do a brute force assessment on this. So it's literally try every combination of every parameter that we could make, that we could think of. I stripped down the seasonal term because I was thinking it's either going to be monthly or monthly relevant, quarterly relevant, half-year relevant, or annually relevant, just to limit the state space again. So you end up with 264 combinations in this. And you get a meaningless number that if you do your research, it basically says the lower the better. So now, these don't look all that different from the order statement that we had before. So I think the only difference was I didn't have an integral term in the seasonal, and I didn't have a autoregressive term. What does that mean? This, and I know we're getting tight for time, we'll make it. That red line is where the very first version, pulled out of my arsehole model was. And this is the full state space, the error rate of the full state space. And basically, we've now managed to sort of take 30% off it by actually exploring that state space. So be careful with your models. And by tweaking that, we get a slightly more positive view on the world. Enough that you could go, yeah, okay, that looks good. I'm now happy with that kind of prediction. So earlier, I stripped this down to 2019 and just said, right, okay, let's hope that it hasn't been affected by anything. Just care about the data up until 2019. But whenever you reintroduce that data, it actually seems to fit it relatively well. So I'm kind of going, oh, this time series shit isn't actually fake. Okay, right, sweet, right. Seems to fit reality. That's good enough for me, so, oh yeah. Now, this is why I said we're going to be done. Next steps, aka what I wanted to do with this talk, but totally screwed up. Sorry. No, I will not rush through that one. But yes, I had time management issues, ironically enough, doing time series stuff. But what we want to do, I want to continue this project and build up additional models for effectively all of the other state streams and bringing in those exogenous factors that are outside of our control. We want to, if anyone's good with probabilistic combinations, please get in touch because I am having a stats failing. And if anyone wants to help, go for it. And then starting to investigate the Varimax or the similar proper multi-dimensional ones. And you can talk to me about this, but this is all the fun stuff that's happening in the hackerspace next time round. So, that's it. Thank you very much for your time, folks. And I'll take any questions that anyone has. One at the back.
So guys, one question, please. We have 1 minute.
In your predictions, in your forecast, do you use the number of members? I mean, for the future, do you use it as input?
No, there's an interesting problem with this, which is, ironically enough, so we're moving to Nexus as a membership management system. As it stands at the moment, there are 5 ways that somebody can register as a member at Farset, because there are people who don't want to use PayPal, there are people who don't want to use credit cards, there are people who don't want to use cash. We've had people try and pay in Bitcoin before, and we had to tell them, our accountant does not accept Bitcoin. So there hasn't actually been until this year a solid number on how many members we have, and going off the cash flow was the easiest way to do the assessment. The second problem with that is that even if you did put it in, it's not going to help because that's not really the right dynamic for the model. Because if you already have the predicted members, because we know how much we're charging people for their membership, we know what that model is. It's literally, you're effectively doing a distribution breakdown on the type of members rather than anything that we can do forecast. So I intentionally tried to make this as stupid as possible. Just look at the history, how noisy has the past been, and can we have any confidence in the future?
Okay.
Right.
Thanks.
Okay, thank you so much. Wait.
Grab me afterward. Thanks very much, everyone.
Thank you, Andrew. So please, any more questions outside? Thank you.